Hello, everybody, and welcome to my channel. I am Konyedi Olodu, and once again, I will say welcome to the channel. This is a platform where we teach and share information on structural engineering designs. So once again, I will encourage everyone to subscribe to this channel so that when subsequent videos are being uploaded, you can get the notification immediately. So thank you, and we will be talking about understanding the fundamentals of structural engineering drawings. That is our topic for today, understanding the fundamentals of structural engineering drawings. So we dive right in. The number one thing you need to know as a structural engineer or any of the engineering discipline or even architect is your drawing is how you express yourself to the artisan or to whoever will be carrying out the design. Those that are doing the construction, they need your drawings, your detailing to tell them what you have in your mind, the calculations that you've done. You need to express it through your drawings. So for every engineer, the understanding of AutoCAD drawing is very, very important, or whatever software you choose to express what you have designed is very, very important. But this AutoCAD has been one of the best platform by which engineers expresses their knowledge. So for we to start the process where we need to understand the fundamentals of structural drawing. So we'll bring out the outlines, what we'll be learning from this video, what we'll be learning from this video tutorial. So our course outlines, the first thing will be learning will be general arrangement of structural working drawings. The next thing would be placement of the reinforcement in the structural elements based on the bending moment diagrams. The third thing we will learn from this video will be curtailment, anchor length, and lap length of reinforcement. And finally, how to call out reinforcement. If you have a good understanding of these four elements, then you'll be very sound in your structural working drawings, how you detail your design, so that anyone that sees your design will immediately understand what you are trying to tell them or the instruction you are trying to give in executing the projects. So stay tuned, because each of these things we'll be talking about will be very, very important to us. So let's dive right in. So this is the floor arrangement. The floor arrangement, this is what we will be achieving at the end of this video for us to understand the structural working drawings. So from our outline says we need to understand the general arrangement of the structural working drawing. So if we are doing design, we design from roof down, but when we are doing detailing, we detail from the foundation up. So let's dive right in. So if we look carefully, this is the general arrangement of structural working drawing. The first thing when you are doing your detailing, these are the sequence, but other things can be added to it. But the number one thing we need to know is our cover page. The cover page tells you the title of the work, the location, the client name. Very important. This is the first page you will see in any working drawing. This sequence is basically what you follow. Then the next thing we need to see is a general notes, the foundation layout, foundation section. If you are using pads foundation, then the pad foundation detail, whatever foundation. So if you notice where the first set of drawings are our foundation, the next is column, the other one is staircase, so it goes in this direction. Then you see your first floor slab layout, first floor slab detail, your first floor slab section, your first floor slab beam, first floor beam detail. But if you have subsequent floors, second floor, third floor, they come right after this first floor beam, so the sequence still follow. If you have two floors, it becomes second floor slab layout, second floor slab beam, second floor slab section, then second floor beam detail, depending on the number of floors that you have. Or if not, we just have a single floor, so that's why we used first floor slab. Then the next thing we need to do is the roof beam layout and the roof beam detail. So that is the general arrangement of your drawing, like what we can see here. This is our cover page. This is our cover page, which shows structural working drawing of proposed residential development at plot XX X zone BBB for Mr. XYZ. So you put your client's location here and your client name here. So this is it. Then this is the general notes, which says this your drawing, what it is all about. This is the general note, this is the concrete, and this is the block work. These are things that the instruction you are giving to them. Then this is our floor foundation layout, our foundation section. These are pad details. These are pad details. This is our column, and this is our staircase. Then our first floor slab layout, then here becomes our first floor slab detail. These are the detail, and this is our first floor slab section. Then we have our first floor slab beams. Then here is our roof layout. From there we have the roof section, then the roof beam detail. So with that, typically this is how you do your arrangements, or you can you can maybe add one or two things if it's not here, but basically this is the arrangement. If you follow this sequence, then your work will be very neat and proper. So the next outline says, placement of reinforcement in the structural element based on the bending moment. So if you look at if you look at our work, the bending moment, if you look at this, this is the bending moment for a continuous beam or a continuous slab. If you see how the moment is, it shows you how to reinforce your structure. So with this, you know your bottom slab, your bottom moment, you have to reinforce the bottom all through. But for this top, the maximum bend support moment is only at these intervals, so the rest will be just minimum reinforcement. 2y16 would do, but whatever you design for your reinforcement to be able to carry the load, then you design based on this moment that is there, based on the moment that is there. So this is for a continuous beam or slab. So if you are detailing, you understand why you are curtailing. Instead of you to run, if this top support moments gives you, let's say, 4y16, so for you to run 4y16 all through, it will not be economical. So you have to curtail it at this point where the moment is at the highest. So we do that. If we look at our work, this is our work. Your beam, this is our work. Now if you look at this is the support, the span moment, that after the design, this is what it is. Then this is the top bars that has been curtailed out. So based on that, it will determine how you put your reinforcement. So based on that, if you are having a simply support beam, if you want to detail that, you find out that this the top doesn't really have movement. Yeah, this is a simply support. So your main reinforcement, it will be on at the bottom, while the top will just be a nominal bar. Very, very important that you understand this. When is a continuous beam and when is a simply support beam, and also when is a cantilever. If you notice, the moment is on top, so you must reinforce the top more to carry the load that the bending moment that this cantilever has created. So based on that, if there's a cantilever, the main bar are always on top. The main bars are always on top. So you must understand that the main bars are always on top. So as we are saying, we've discussed about we've discussed about cantilever moment bending moments. We've discussed about continuous support moments and simply support moment. If you understand how it works, you interpret the drawing properly, and whoever is using your drawing on the site to construct will find it very easy to work with. So that is it. So for the next outline is our lap length, curtailing, and the anchorage. So in beams, okay, we say lap length. Now if you want to lap a bar while you are constructing, it is either two ways. You can either use, if you are doing this, let's look at this. It says 50D. D is the bar diameter that you are trying to lap. So but you are trying to lap, let's assume you are trying to lap a 12 diameter, Y12. So it says 50 times 12. So the minimum lap length for diameter 12 is 600. So the lapping between the reinforcement must not be less than 600. That is for lap length. So whatever you do, if it's now you want to lap diameter 20 times 50, that means it cannot be less than 1 meter lap length. So very, very important. We have to pay attention to that when we are lapping. Then when it comes to anchorage or curtailing, let's say we are doing curtailing. If you want to curtail, that's since the bottom moment will go all through here, but for the top moment it's not starting from here up. So the area at which it will cover, it will be 0.25 L, or you can say 1/4 of this length will be what the top bars, where the top bars will be really effective. So every other one can be a nominal reinforcement. So from here 0.25 L, whatever this thing is, multiply it by 0.25 to give you the curtailed length. Why? If it simply supports, or this part will be length over 3, 1/3 of the length. That is what we do, curtailing of the bars. This one is 1/3 of the length That is what we do. Okay, so but for the hook anchorage length, if you are doing anchorage, yeah, if if the anchorage, if we are doing something like links and the rest, that it will have to turn all through, the anchor length should be 4D, where D is the diameter of the bar. 4D, let's assume you want to do 4, the diameter is 12. So it is either you use 650 as the minimum, since 4 times 12 is less than 65. We use 65 as the anchor length. That is when you are doing something that is on 90 degree 180 degree turn. But if it's not that, if it's a 90 degree turn, it becomes 12 times D. 12 times D. 12 times D. If we say our D now is 12 diameter, so we'll be having nothing less than 144 bend. So very, very important to understand that. It is very important that we understand that. Okay, so finally on this is about how do we call our bars. How do we, this is how you call your bar. This is the color mark, a call mark, that it shows that this reinforcement spans from here to here, to here, and to here. Whatever this arrow shows you is where this reinforcement spans from. If we look at this number, this is the number of the bars. How many bars? So there are, let's assume you have 10 here, you have 6 here, you have 8. If you add it up, it will give you 24 number of bars at Y12, which shows the diameter of that bar. Then this is the call number, and this is the spacing. T signifies either is on top or bottom. So for you to get this 20, how did we arrive at this number? Is, if you look at this, if you measure from here to here, if you look at this, it's showing us 2625. We are saying 2625, but you know we are measuring it from in to in, so the wall or the beam is removed from it. Now we remove concrete cover. Let's say we remove 50 as concrete cover. Now divide it by the spacing. We say 200. If we do that, we say plus 1. Let's do it again. We said if you measure that, if we measure the from in to in, we measure in to in. If we measure in to in, it's giving us 240. And we remove let's say we remove the concrete cover divided by 200. Our what we are having is 11 plus 1, it becomes 12. So your call number becomes 12. So if you add up all of them, this 12, let's assume if this thing is running only here, let's assume something, I'm trying to assume something, if is running only on this direction. Let's assume this for quick understanding. If this bar here is running just from here to here, with our calculation now, here becomes 12, so we'll say 12, which is the number of the bar, y 12, which is the diameter of the bar, then 08 means this bar, for the bar that has 08, they must be of the same length, the same diameter, and the same shape. So you give it 8. Y 200 is the spacing, then T, which is top or bottom. So with all this, you understand how to arrange your structural drawings. You've understood the fundamentals of the detailing. When you are detailing your work, these are things you need to pay attention to while detailing your work. So this is what we'll be doing today. If you have any question, please let us know. If there's any parts that you really don't understand, feel free to comment on the comment section, then we'll be glad to explain it further and better. So once again, I will encourage you to subscribe to our channel, like the post, share the post, and whatever the question is, feel free to let us know. Till we upload more of the videos, remain blessed. God bless you. Thanks.